How's it going? Welcome back to another video on Code Tech Tutorials. My name is Matt. It is really early in the morning, so sorry I'm slurring a little bit. I'm still waking up, but I just wanted to go ahead and finish this. It was on my mind last night. I had started this new CPP for school labs thing, and basically I was just going to go through all these labs starting from the beginning, and I think this will make kind of a nice little series to just go through all these from start to finish, explain everything, and that should maybe help people get into C++. So we're on the very first one still, so if you want to follow along and learn, now is a good time. If you want to wait till a little later when things are a little bit more difficult and advanced, if this stuff is too easy for you, then consider maybe subscribing and checking back later when the series is further along. I'm going to try to do these as often as I can manage. So we did the first 5 in the last video, and they were pretty straightforward, but it looks like now we're getting into a few more things. I just want to knock out 6, 7, and 8, and we're going to do the same thing here. I'm just going to open Visual Studio Code on this vars set1 folder with this command and sigwin. So I'm using the command line sigwin, which is basically a Linux terminal on Windows, and it's spelled CYG WIN in case you want to go look that up and grab it yourself. That's kind of a separate thing. Alright, so 5's done, and we want to look at 6. And the question here is, let's see, write a program which accepts a character and displays it as its ASCII value. So in case you don't know, let's look at ASCII chart. Every character is represented by an integer number. Here we go. And the reason why is because a character is 8 different bits, or as a binary bit in a computer, you can signify every character. So like the number 8, for example, looks like this in binary. And then we go to the characters, and we'll find, okay, all these symbols like the letters of the alphabet. Like capital T, for example, is this, and the ASCII code is 84. So to do what we're intending, or what it's talking about here, and you know what, I'm just going to comment out these old prompts because we don't want a bunch of prompts stopping us from doing what we're doing. So there we go. Those are all the old ones are commented out. And I'm not going to make the mistake I made last video, and I'm actually going to have a little bit of a wider screen this time. There we go. Need more screen real estate. The never-ending problem of being a coder. Maybe I can do it like this. That's not too bad, actually. I don't mind that. Get out of here, cookies button. Got it. Okay, so there's some ASCII codes. Let's go back to this. Write a program which accepts a character and displays its ASCII value. I almost said variable. So we're going to need a character for the input, and we'll just call this answer. And then we're going to need to cin it. So of course, cin is console in. Let's do a console out first here, and just let the user know what's going on. That's always a good idea. That way they're not just totally lost when a prompt comes up. So this will say character to ASCII translator, and then new line, and then enter a character, and then we'll prompt after that. So we need to store the character, so we're going to go ahead and make that, and then we'll do a cin of this answer. So that'll sit there until the user presses a key and presses enter. And what we're going to do is take this answer and just print it out as its ASCII value. And to do that, there's a couple different ways. Let's do a new line here, and we'll say, let's say a new line, a little quote symbol, which we must put a backslash in front of so it doesn't recognize it as a different character. And then this variable, and then we'll finish that. It's going to be surrounded by this little single quote, and then and we'll space is ASCII value, and then we'll print the ASCII value of the whole thing. And there we go. I'll use this, and to print the ASCII value, we basically need to cast this character as an integer. So what that means is, well, if you look at this decimal number, well, integers also have a binary setup. Looks like we can't see the rest of this. Here we go. So integers also have a binary number because they're 8 bits wide as well, just like characters. So you could take the memory that is stored as a character and say, okay, if that were an integer, what would it be? So that's basically what this whole thing is just because characters and integers have the same width. That might not be true for all compilers, so take that with a grain of salt. But and check your compiler's details if you're not entirely sure. So basically, the old style is to just do this: put in parentheses int, and then right after it the variable, and that will cast it to an integer and spit it out there, and that should give us the right answer. But this isn't this is, like I said, the old C way. I'll show you the C++ way. But let's go ahead and run this and just confirm that it works. So we're going to do our little make run command. Let me find it. G++ main.cpp and a.exe. Okay, so that'll compile it and then run it. Enter a character. Let's press the character P. Enter. P's ASCII value is 112. Let's confirm. We'll find the number 112, and that looks like, oh, that's HTML symbol. We want this one. There we go. Yep, it's a lowercase p. So there we go. That is correct. Now, the new way of doing this, if you're using C++ and don't want to use the old C stuff, is you do a static cast as an integer, like so, and then you put the variable in parentheses like that. So this is the newer way of doing it. I guess it's a little safer. I'm not going to say too much about it, but you'll see it both ways basically. Let's put P again, and we get the same thing. So I'd recommend, if you're using C++ in general, to do the static cast method. It's a little more verbose, but it's also, there are advantages too. I'm not going to get into that too much. Let's just continue. If you want to look up more about it, do look into static cast. It's something you can Google, and if people really want, I could talk more about it, but we'll move on for now. So let's go on to 7. I'm trying to keep these 20 minutes, so I'd like to get all these knocked out. I think I've done enough preamble, and I just can talk. And and I can just continue. Write a program that swaps the value of 2 variables. Easy. Okay, so let's get a C out. Swap 2 variables. So just letting the user know what's going on, and we're going to ask for var1, and then we'll declare 2 variables. Now, it doesn't say what kind of variables, whether they're characters, integers, whatever. We're going to do them as strings. String var1, and strings are part of the standard. We'll just have to include string up here. It's basically an array of characters, so there are other ways to do this, or we could do this with numbers, but we're just going to do this var1. We'll also do var2. We'll go ahead and just declare them both there while we're at it. And we're going to do a cn var1, and then we're going to prompt for var2 here, and we're going to need a new line, because otherwise it's going to appear all jumbled together. And we'll do a standard cn of var2. And then what we're going to do is we're just going to swap the values. So the way to do this is you basically, well, there's some ways with moving it around memory that can be more efficient, but the most straightforward way is to basically make a third var, just called like temp or something, or holder. I'll just call it t holder. And basically what you do is you say, okay, well, we want to swap these, so we want var2 to be var1 and var1 to be var2. So something's got to be in the middle holding that while it's going on. Okay, we'll just prepare the output here. Swapped var1 is now, and we'll say var1 here, and that with a new line. And we'll do the same thing with var2, so it just spits out the in there. So this little section right here, which I will scope, that way this temp doesn't stay in scope after doing this whole work. And basically what we're going to do is well, t holder is now going to equal var1, and since var1 is now being held, we can assign var1 whatever var2 is, and var2 is now going to equal whatever var1 used to be, which is now held in that t holder. And boom, we've done a swap. That easy. And as this goes out of scope, this t holder will deconstruct and no longer exist, but of course var1 and v2 still will exist and be swapped. So as we go down here, these should now be correct. Let's go ahead and run this. Same command, so I'll press up. There we go. And swap two variables. Variable 1, we can type in any string. I'll just put my name, Matt. And var2, I'm going to put, I don't know, cool. I'm not saying I'm cool, but I am. And now we swapped them. So var1 became cool and var2 became Matt. And boom, there we go. So we swapped. There is an algorithm for swap, so there is like a include swap, and like so, I think. Or it might be in something else. Is it in memory? I don't know. It's in one of them. Anyways, I don't want to go down that rabbit hole right now, but basically there are some built-in functions you can use to do this automatically too if you're not sure how to write your own for the particular variable you're using. If you're using your own class or something, you got to write it yourself. So there's that. But hopefully that is enough to help you get started. Let's see, 8, write a program to calculate the area of a circle. Area of a circle is, of course, pi r squared, times r squared. So it'll look something like this. We'll just say cout calculate the area of a circle. So that way we know what we're doing. And basically you just want to get the radius, and you can take it from there. So you want to do a float for the radius, and then we'll just prompt for it. So we'll say cout, enter the radius. If I can spell, semicolon there at the end, and then a cn radius. So there we can enter a float for that, and then we can just calculate it and show the answer, and say something like the radius of your circle, or wait, let's see, the area of your circle is, and we'll just spit it out right here. Keeps doing that. Keeps adding two quotations when I try to end the quotations. That's driving me crazy. And then we can just do the formula in line here, which is going to be radius times, and then we want to do, well, we want pi 3.14. It's going to be close enough. There's a pi constant. I think it's m underscore pi, but we don't see it unless we import. I believe it's math. Include math. CMath? CMath? And does that show up now? No. So I don't remember where it's at. It's in one of these headers. I could probably find out with a quick Google search. MPy and C++. Voila. It's defined in math.h. No. Someone else corrected. Use math defines, and then, okay. So we could also do a hash define, or we could do the other ways of doing it. Whatever. Let's just put a 3.14 in here. So basically we could declare it ahead of time somehow or from one of these headers, but it's just the number pi. So however you want to get it, just do that. That's fine. So we do the radius times the radius, of course, for squared. There's also from the math header, I believe it's power, but of course squared is just radius, is just the same thing times itself. So we'll put those in inner parentheses, that way that it calculates the radius first as we intend. And let's put a new line here at the end, new line character. And there we go. Well, that should get us the radius. So let me go ahead and compile and run that. Alright, enter the radius. Say we have a radius of 5. So we get the area of 78, which of course is 5 times 5 times pi. And there we go. So that should be the correct radius. Let's go ahead and knock these last two out. Number 9, what is number 9 on here, is write a program to check whether a given number is positive or negative using the ternary operator. So the ternary operator is a way of doing if else, and this is really odd for them to ask this here because flow control is in the next set. So they're asking in set 1 on number 9 for us to do flow control when flow control is part 2. What? Stop. Just what? I don't understand tutorials who do crap like this. Like, do something before we teach you how to do it. Good luck. Anyway, okay, so let's positive or negative. So then we'll just do cout, enter a number, and then we'll do float some number 1, standard cn number 1, and then we're going to use the ternary operator here to spit out whether it's positive or negative. And we'll say number, well, wait, we need the variable here. Number 1 is, oh, we need a space. And here's where the ternary operator comes in. So we want this to say positive if it's positive, negative if it's negative. So we need in parentheses our condition that does a check. So if we say number 1 is less than 0, for example, then we're going to say it's negative. So we'll spit out negative. And otherwise, we use this, and so if it's not less than 0, if it ends up being greater or equal to 0, we will say the word positive. And there we go. And then we'll just go ahead and throw a new line character at the end here. So this whole section right here is the ternary operator. What does it not like about this? Oh, I need more to it. So it returns negative or it returns... Oh, I'm sorry. I got these mixed up. I think. Do I? No, I don't. Let's do a 0.f there. And we might have to do this a different way. It doesn't look like it's going to like it. Let me just... maybe I have to have the entire thing in parentheses. I think I do. Yeah, in this case, having it in line like this, I'm going to have the entire thing in parentheses. And I forgot to do a new line right here. So that's why those are jumbled together. So enter a number. Let's do it -5. And it says -5 is negative. Let's run it again. And this time we'll enter a normal 5. And it will say 5 is positive. Okay, so that was a little trip up. I just needed to surround the entire thing in parentheses. But as you can see, it's the condition. If the condition is true, it returns the first thing. Otherwise, it returns the second thing. So that's how you do those ternary operators. And it looks like we went one more to check for even and odd using a ternary operator. So I'm just going to duplicate all this code right below and comment out the old stuff here. And this is numero 10. So, and this is going to be an even or odd set. So enter a number, number 1. And one of the things we can do here, in case we uncomment them all and try to run them all, is just scope this one. That way we don't see number 1. Since we're repeating a variable, if one's in a different scope, then it won't complain. So that way we could actually do both of them like this, and see there's no underlining errors. But if we took this scope out, then it's going to have this weird error where, oh, you're declaring the same variable twice. And of course the compiler won't like that one bit. So there, we'll just throw a scope there is all I'm doing. And that's just kind of a little side thing. Okay, so even or odd, we're essentially going to do the same thing, except we want to say we want to use a modulo. So if number 1 modular 2 is equal to 0, then it is even. Otherwise, it's odd. What am I not doing right about this? These are floats. Floats aren't so easy to do with even and odd, so we're going to do integers here, just whole numbers. So maybe we'll rename this. Nah, that's fine. So this has got to be a whole number, of course, do even or odd. And there we go. So basically what this does is a modulo. It divides by 2 and sees what's left over as it keeps dividing by 2. So if it's odd, it'll end up equaling 1 and go to the second case and say odd. And if it's 0, it'll say even. So that should just work, and we'll be done here. So I'm going to go ahead and run this, even or odd, enter a number. Let's say 95. And it says 95 is odd. We'll do it again, and this time we'll say 96. 96 is even. Very good. So thank you for watching this video and for following along. Hopefully this helps you get into C++ and learn some of the basics of how these initial labs work. I'll see you guys in the next video. Peace out. Keep coding, and do what you can to love life. It's a crazy world out there, and it's up to us to make the world a better place. So just remember that odd thing I'm throwing in at the end of this video. Peace out, guys.